Hi everyone, hello again. We are going to continue talking about linear modeling of certain things in the quote-unquote real world. And we're just going to, this is section 2.2, and we're going to do 3 examples here, which basically you're asked to find the equation of a line that relates 2 variables, where the 2 variables actually represent 2 very real things. In this first example, we're given that the number of rushing yards per year by a running back of a team has decreased linearly from 1835 yards in 2004 to 20 yards in 2009. If we let R represent the player's number of rushing yards in the year that is T years from 2000, then we're asked to find an equation relating R and T. Now the key word here is decreased linearly. That means we can write the equation is going to be a linear equation. That is R. Now we're letting T represent time, so time is almost always the independent variable. So that means R is going to be a linear function of T. So R is going to be in the form of MT plus B. Okay. And we have to find what M and B are. Okay, so we're given 2 pieces of data. 2004 corresponds to T equal 4, and we're given that R is equal to 1835. 2009 corresponds to T equals 9, and for that year R is 20. Okay. Now this really corresponds to 2 points. If we let the first coordinate be, let's try this again. If we let the first coordinate be T and the second coordinate be R, then then T, we see when T is 4, R is 1835, and when T is 9, T is 20. So these are the 2 points that we are working with in this case. So so if I asked you to find the equation of the line that passes between these 2 points, we should be able to do that. It's just instead of x and y, we're going to be using t and r. So this m is going to represent the slope. Okay, and it's going to be the change in the quote-unquote y-coordinates. In this case, it's the r-coordinates divided by the change in the x-coordinates, or in this case, it's the t-coordinates. So this would be 20 minus 1835 divided by 9 minus 4. And this turns out to be negative 1815 divided by 5, which is negative 363. So that is our slope. Now to find B, we just plug one of these 2 values in for R and T. We'll choose this one because it has smaller numbers. So here R is 20 and T is 9. So 20 is equal to M times 9 plus B. And so this will be, so 20 is equal to negative 3267 plus B. We can add 3267 to both sides. And we get 3287 is equal to B. Okay. So our equation is going to be R is equal to negative 363T plus 3287. Okay, so that would be the linear relationship between R and T, between the rushing yards and the T and the number of years after 2000. Once again, we use the T years after 2000 to keep the values of T relatively small, and the calculations simple. All right, let's look at another example. Here we're given that the percentage of soldiers unavailable for combat has increased linearly from 10% in 2008 to 18% in 2011. If P is the percentage of soldiers available for combat T years after 2000, find an equation of a linear model to describe the data. Well, it's the same thing. The key word here is linear. And actually, the really important one that we want to see is right here. All right, so we want to find a linear relationship between P and T. So P is going to be MT plus B. And once again, when T is 2008, whereas in 2008 T is 8 and P would be 10. And in 2011 T is 11 and P is 18. Okay, so T corresponding points, if we're on this line, would be 8, 10 and 11, 18. All right, so our slope, M, our slope is the change in P divided by the change in T. So this would be 18 minus 10 over 11 minus 8. This turns out to be 8/3. Okay, and then we'll pick one of these points. I guess I picked 8, this first one here. So we know that P now is 8/3 T plus B. When T is 8, P is 10. So 10 is equal to 8/3 times 8 plus B. Okay, if you don't want to, if you want to work before you take out your calculator, if you want to do it this way, this is 64/3 and this is 30/3. Okay, so you can subtract 64/3 from both sides. And this will turn out to be negative 34/3. And that's equal to B. So P is going to be 8/3 T minus 34/3. Okay. Or if you want to use the decimal approximations, we could say that P is, if we round to 2 decimal places, this is 2.67 T minus 11.33. Okay. Either one would be acceptable for me, by the way. All right, last thing, last example here. In this case, the average length of a 4-year-old fish is 27 inches, and that of a 19-year-old fish is 54.3 inches. The age and length of a fish are linearly related. Find a model to describe the data. Okay, by now we know that means finding an equation, a linear equation. Well, let's define some variables. First, I'm going to let L be the length of a fish that is A years old. Okay, where A will let A represent the age. So we're trying to find an equation like this, where L, so L is going to be M, A plus B. Okay, and we want to find what M and B are. And we're given that when, so A is the independent variable. So our 2 points are, they're given when the age is 4, the length is 27, and when the age is 19, the length is 54.3. Okay? So what we do is we're going to do exactly what we did before. We will find the slope and then find the y-intercept. So I'm going to let you pause the video and do it yourself. And here is what happens is the solution. The slope turns out to be 1.82. So the equation is going to be in the form of L equals 1.82A plus B, and plug in L equals 27 and BA equals 4, and we get that B is 19.72 when we do the calculations. So this would be the equation that describes the data and gives the linear relationship between the length and the age. All right, and a lot of problems are like this in your homework. Good luck, and I'll see you next time.